Hello students, welcome to Mathematical Thoughts, student learning initiatives. So today we are going to discuss a very simple and easy but a very important question, or you can say theorem. So let's begin with the question. The question says that let R belongs to R real number, prove that there exists a sequence of xn of rational numbers such that limit n tends to infinity xn equals to R. What does it mean? Let's first understand the question. So in this question we have to find a sequence of rational numbers. A sequence of rational numbers means the terms x1, x2 and x3 and so on. The terms x1, x2 and x3 must belong to rational numbers. So we have to find a sequence xn which converges to real number R, and note that here R is an arbitrary number. So let's begin the solution. So if R is a rational number itself, then we can take xn to be a constant sequence. That is xn equal to R for all n belongs to n. So we know that xn is a one constant sequence, then it comes to the constant term of R, of the sequence R. So nothing to prove if R is itself a rational number. So the otherwise the main part of this question is if R is a irrational number, or in general if R is a real number, then how we find or construct a sequence xn which converges to R. That means, and we have to show the existence of such sequence. We need not necessary to find exact sequence for any given real number. We can't find always a exact sequence, but we show in this question that in this theorem there must exist a sequence. So let's begin, and it requires one thing, and you must know that density property of rational numbers means in if a and b are two real numbers such that a is less than b, there exists a rational number q such that a is less than q less than b. What does it mean? Means if we take any two real number, there must exist a rational number between them. And another one is we will use later case Archimedean property. Okay, so when we will discuss that property, especially the statement, and we assume that you know the proof of these two theorem. If you don't know, so you can ask in comment, or we will upload another video for these two theorems. So okay, let's come back to this question. So we are going to construct a sequence xn. So we are going to use the density property of rational numbers. That is, given any two real number, between them there exists a rational number q. So in the notation with the above, if we take a equal to r minus 1 and b equal to r plus 1, then a and b are real number. Why? Since r is real number, so minus 1 is also a real number and plus 1 is also a real number. So by the density property, we have a rational number, say x1, we are calling it x1, such that r minus 1 is less than x1 less than r plus 1. Now we take a equal to r minus 1 by 2 and b equal to r plus 1 by 2. So we have a rational number x2 such that r minus 1 by 2 is less than x2 is less than r plus 1 by 2. So you can now guess the next terms. So similarly we have rational numbers x3, x4, xn and so on, such that for any n belongs to natural number, r minus 1 by n is less than xn and r plus 1 by n is less than. So xn is r, all are rational number. So we have found that the sequence xn, x2, x4 such that this. So now we consider the sequence xn of rational numbers. Let us check whether the sequence xn converges to r or not. So how we construct the sequence xn of rational numbers? We just take 1 by n and subtract r minus 1 by n and r plus 1 by n. So we know that these two a and b, there exists a rational number. So we say xn for each n. Okay, now note that r minus 1 by n is less than xn is less than r plus 1 by n. This implies that xn minus r modulus is less than 1 by n for all n belongs to natural numbers. Now we use Archimedean property. What is Archimedean property? It says that for any given real number, there exists a natural number m such that m is greater than epsilon. So that's the equivalent condition is that for a given epsilon greater than 0, there exists a n belongs to natural number such that 1 by n is less than epsilon. Now combine this point and this point. So for what we get, for all n small n greater than capital N, this means we take inverse both sides. So 1 by small n is less than 1 by capital N, and 1 by capital N is less than epsilon by above. So what we get, xn minus xr is less than 1 by n from here, is less than epsilon for all n belongs to n, and this is the definition of convergence of any sequence xn. So this implies xn converges to r. So you can see it is very easy construction, but many students finds difficulty in earlier when they start reading sequences and these properties of convergence of sequences. So we think that we should make a presentation or a solution of this question.